Hi, good morning to those in the US and good afternoon to everyone in the UK and across Europe. And welcome to the first of our Q&A webinars, which are designed to be driven by you, our users. Firstly, by way of introductions, my name is Ben Daniel, and I am the Director of Customer Delivery and Support here at Eggplant. Today, I am joined by Randy Hesse, who is one of our technical consultants and who is on the front line of working with our customers on a daily basis. So we first had the idea to run these Q&A sessions after we'd had a number of questions from users who had been taking our certification courses, but who then had additional questions on how they could learn more about the features and functions that they were reading about in the course material. So we're starting this series with intelligent image-based testing, and Randy's going to answer all of those questions that we've been collating from you over the past few weeks. If during the course of this discussion you have a question that you'd like to ask, then please let us know via the question panel of this webinar, which should be just underneath the presenter's screen, and we'll make sure that we answer all of those questions at the end of Randy's presentation. If you also have any suggestions for us about other subjects that you'd like to see us cover in future Q&A webinars, then please also let us know via the questions panel. So, without further ado, I'd like to hand over to Randy, who will answer your questions on intelligent image-based testing. Take it away, Randy.
Cool. Thanks, Ben. Hi, my name is Randy Hesse. I'm a technical consultant here at Eggplant, and I will be covering understanding image-based software testing. All right, so let's go through the slide deck here. So, what are we going to cover? So the first thing we're going to do is kind of cover our testing approach, and basically, we can't talk about image recognition or image-based testing without talking about objects. So we're going to talk about a little bit of object-based testing and then image-based testing. Then I'm going to go into some detail about images and what they actually are, how they work, the technology around images, just a little bit more detail. And then within that is why people consider images to be flaky. After that, how Eggplant kind of works with images, how we look for images on the screen. We do a few different techniques. Those are listed there: precise, fuzzy logic, tolerant discrepancy. So I'll go into some detail about exactly what those are. And then finally, I'll conclude with the future of image recognition, right? What does the future of looking for images look like? What's out there now, and where are we going? All right, so moving on. So let's talk about testing approach. So there are two fundamentally different ways to do testing, and that's object-based and image-based. So object-based testing traditionally has been about objects. So testing around Selenium code, Selenium, Appium, Winium, these were pretty much considered the standard for testing for a long time, and that movement has been kind of changing. Object-based testing allows us to verify and manipulate attributes and properties from compiled code. So basically, we can look at the underlying code. On the right-hand side of the screen, it's just a screenshot of kind of the web drivers, information about like kind of Selenium and what it looks like. And obviously, we're going to a lot of bit of images. Now, for, as mentioned, right, there's traditional testing. For objects, there's also no GUI, so it's a little bit faster interaction, so meaning you can get through testing just a little bit quicker than from an image standpoint. Same objects use different browsers, so you can look for the same header or the same HTML path. It wouldn't matter what browser you're on, whether it's IE, Mozilla, Firefox, or what have you. And of course, as I mentioned previously, you can manipulate manipulation of attributes and properties, making sure the alts are correct, the links are correct, you can just, the height, the width, any of those kind of properties you can kind of change with and adjust. So those are kind of different, those are specifically around objects. For image-based testing, easy to understand. Does the image of a dog appear on the screen or not, right? Yes or no, what objects do that, like looking at the divs, the height and weight of the images, or so the height and the width of the image, right, is displayed, is it stretched across the screen, or does it look proper? What's nice about images too, it's easy to learn. There's no engineering background required to understand for looking for images. Again, it's just, does this image appear on the screen? Image also allows us, not only does images allow us to deal with multiple browsers, right, making sure that image appears across multiple screens, but across multiple platforms. How does this image look on, again, Mozilla, i.e. Windows, Linux, or, Mozilla, i.e. Windows, or how does it appear on like Linux, Mac, a point-of-sale terminal, or maybe an Apple iPhone, or maybe even a Samsung device, right? Across multiple platforms, we can look at the image. When we go from the object-based world, we can't really do that across multiple devices. And the most important thing that images allow us to do is to come from the user perspective. The user perspective allows us to test the application in a way that is truly important. How does the user interact with the application? The user interacts with the web application exactly the same way they interact with a board game, with pets, with cars, or any other object or other people. So how does that interaction work? Humans interact with the world in any application they use using the 5 senses. So again, humans have 5 senses: the eyes to see, the tongue to taste, the nose to smell, the ears to hear, and the skin to touch. By far, the most important organ of sense are our eyes. We perceive up to 80% of all impressions by the means of our sight. And if other senses such as taste or smell stop working, it is the eyes that best protect us from wrong danger. So the human senses is how we interact with anything in the world and any application on the internet. And you kind of believe me in that, right? It's pretty hard to describe like what apple pie smells like. It smells like apples. Describe to me what death metal sounds like. It sounds like a bunch of guitar riffs. What does the guitar sound like, right? But what about like describe to me a car you drive? Well, it has 4 wheels, right? I've seen 4 of other things. I have like 4 fingers, so that makes sense. Wheels are round objects, right? I know what a circle looks like. What's the color of those wheels? It's blue, but is it a sky blue, an ocean blue, sky blue, regular blue? Is it smaller than a bread box? Is it bigger than a house, right? Size, shape, color are just ways of describing an object, but we can use other visual references to identify what we're seeing. So when we talk about, why am I talking about human senses? How is this related to testing, right? We can interact with objects all day long, such as cars, pets, plants, and games. We interact with them. This is the user experience. The user experience is also about application. Testing is not about looking for things. Testing is about understanding and perceiving how a user interacts with your application. I would argue testing is more about psychology than technology because of the human sense and the human interaction. Okay, so a good example about kind of psychology and technology is if you look on the left-hand side of the screen, you see the file menu of Word. And on the right-hand side of the screen, you see some HTML code. Now I always ask, right, find the save button on the left-hand side. I think everyone already knows that. Number 1 is the save, right? Number 2 would be save as, 3 would be open, and then kind of close. But it's easy to look for that save button and automatically identify that because we're looking for that disk. We know most of the save button disks are also blue with kind of that white label. So our eyes are easily to identify that that is the save button versus number 3 or number 4. On the right-hand side, right, we actually have to read the code and figure out what the save button is. In this case, it's more a submit than a save. But we have to see that it's a certain type, it has a certain label, it has a certain ID, and it has a certain value. So this is kind of the difference between like images and objects. Images is, again, that human perspective, human interaction, and objects is kind of that back-end code type, style, ID, and verifying from that end. So let's, again, going back to psychology, let's talk about a real-life example. This is probably one of my favorite examples. Is I would imagine most of you guys drove to work today, right? Let's say you drove a blue Toyota, right? So you drove a blue Toyota to work, you got to work, you parked the car. You then continue your day at work, going over this Q&A, doing some other PowerPoint presentations, answering some emails, so on and so forth. It's now the end of your day, right? What car are you looking for in the parking lot? You were looking for a blue Toyota. You're probably not even looking for a Toyota. You're probably looking for the color blue to go find your car. But what if I said your car suddenly changed to green? Would you be able to find your car in the parking lot? Probably not. And that's kind of the difference of images versus objects, right? You as a person interact with your eyes way more than 80% pretty much of your day, right? If you look for a blue car, you're going to look for the color blue. Now, that being said, from an object standpoint, right, you're looking for the VIN number or the license plate number. But how many people are really actually checking their license plate when they parked in the region? They're not. They're literally going to the region where they think the car is and then looking for the color. They're not sitting there and looking at the plates of every single car. So they are visually interacting with the world, just as you should visually interact with an application. So on to the next slide. Oh, look, it's blank, right? Maybe because if I did image checking, right, it would say that the text is there. But if I did from an object-based standpoint, I can see that it's visually not there. Now, if I press slide, you can see that it slowly fades in. But from an object standpoint, the text was always there. We recognized that the text attributes were there, the bullets were there, right, the correct color and font was there. But from an image base, it was just white. So that being said, right, images versus objects. Which one should I use for testing? The answer is both. Images verify display of the user. Objects verify the property and attributes, right? As you saw in previous slides, right, if the text was white, images, it would fail the image, but it would pass the objects. Sometimes in the objects property and HTML links, we need to verify from the object standpoint. So it is important to test both. They are equally important, okay? I know images always get a bad reputation, but I am here to say that they are both important for testing. But we're going to focus this Q&A specifically around images. So let's kind of talk about the importance of image-based testing. First off, in terms of images and why they're important is when an application is published, your users are not decompiling your application. They are not sitting there clicking the decompile code and looking at the object level. They are literally using their mouse and their eyes and their keyboard to click and use your application and move around and navigate, right? That is nothing the object. It's literally using the mouse, their eyes, and the keyboard to navigate anything. And yet they're able to break their application, right? They're not looking at the code. They're not changing any objects. They're literally just using a mouse and keyboard and visual cues on the screen. And as I mentioned previously, we live in an image-based world, right? Everything is images more than you think. You're literally staring at this Q&A. You're looking at the words on the screen. And you're looking on the images on the right, right? You see there's a stop sign, right? You know that means stop. It has some sort of context. You look at your phone, right? Each icon has its own individual image and picture that goes with it. And way back in the day, right, hieroglyphs, right, to identify words and meanings of some sort of context on the screen. We've been using our eyes for a very, very long time. And that's, again, how we interact. That's that user perspective. That's how we interact with the world. All right, so this is the Q&A. So this is my first kind of stop here for questions. So again, if you have any questions, feel free to type it on the right-hand side. I'll just take a quick moment to pause and see if there's any questions that come up. Then just let me know when you want me to progress.
Sorry, Randy. Yeah, no, keep going, keep going.
All right, perfect. All right, so moving on. So let's talk more about images. All right, so what is an image what is actually an image? An image is a collection of pixels that is represented in some sort of contextual information to the user. So what are pixels? Pixels is the basic unit of a programmable color on the computer display or computer image. Think of it as a logical rather than a physical unit. The pixel size of a pixel depends on how you represent the screen resolution and the display screen. So on the left-hand side are what pixels actually look like. Pixels are made up of 3 different colors: red, green, and blue, or RGB for short. So basically, that RGB value is 1 pixel. So that being said, if the RGB values will turn on and off depending on what color is displayed or depending on what size and shape is displayed. For instance, in terms of color, if RGB pixels were all up and running, that color is white. If RGB pixel is all the way down, that's black. if just the R in RGB, the red pixel, is turned on and the green and blue pixel are turned off, that color is red. Again, if the red and green pixel are turned up all the way, but the blue pixel is not, that color is yellow. And of course, if you turn, as I mentioned, if you turn all of them off, they're black. So on the right-hand side is certain pixels turn on and certain pixels turn off to make a letter, specifically P and 8. So that's how pixels and images work, is they turn on and off to make a shape, and they turn specific colors on and off to make a color. And that's actually what you see. If you actually put your eye to the monitor, especially like a LCD monitor, you can actually see them. You probably can't see them on computer monitors. But that's essentially what pixels are. Okay. So as mentioned, right, most people, when they think of images, they think they're flaky. And I'm here to kind of explain why they are flaky. So they aren't wrong when images are flaky, but we'll talk about techniques, ways of getting around that. So why are images flaky? Well, the two main video card manufacturers, NVIDIA and Radeon, they use different techniques to draw things on the screen. That's why these companies claim that their video card is better than other video cards, because they use different techniques. Because they're using different techniques to draw those pixels and those colors, the images can be different depending on the video card. Another way is also vector image scaling of resolution. Those images don't come as an image, they come as information. And then that information is taken to either scale them up or down. Because of that, how they're scaled and the brand will actually change it. Also, things like monitor process information, so Sony and Samsung. So how companies take the information and draw them on the screen, like Apple, Sony, Samsung, things of that nature, are also done differently. Compression ratio. Cable, right? Video cabling has been changing for years, right? There's been HDMI, DVI, regular monitor, and the cables are RGB, the red, green, blue cables are the RGB yellow, those components versus composite cables. So different compression ratios of how the information is getting fed. Physical versus virtual, right? A physical phone versus a simulator, or a physical monitor versus a simulated monitor, they're drawn differently. These have to deal with things like BNC or RDP for a kind of remote connection. And finally, operating system techniques. Windows 7, Windows 10 will draw them differently because of the different styles, and they'll be drawn differently than Mac or a Linux computer. So these bullets just kind of demonstrate exactly different ways of how images can be drawn. Another operating system technique that I forgot to mention is something called ClearType, which I'll get into a little detail a little later. So, moving on.
Hey, Randy, oh yeah, perfect timing actually, because we have had a good question come in.
Then you kind of dropped off. Ben? So I got a question. How hard is it to do this in EPF? And it's not that hard at all. We'll actually go into some slides a little bit later and demo, and I'll show you how EPF actually handles kind of the Pixar dealing with the flakiness of that. So I'll actually cover that momentarily. Any other questions?
Randy, I'm back. I think I dropped out there. I don't know what happened to my phone.
Oh, yeah. Who knows? Yep. So I answered the question about how hard it is to do this in EPF, which I'll review. Any more questions?
Perfect. Yes, there was actually one before I disappeared. So I had the question about how can this image-based testing help me with accessibility testing?
Sure. So in terms of accessibility testing in images, it's It's really about kind of the color contrast and making sure that the text and background are different from accessibility mode. If, getting back to that slide with the white text on a white background is pretty hard to see. But accessibility testing will allow us to make sure that it's black text on a white background. Things of that nature, as well as making sure that a button is not distorted or kind of half off screen. Again, that's kind of getting back to the psychology too. In terms of the human eye, kind of the cones and rods, it's kind of yellow text on a black background has the best visual context to see from a distance. So all that accessibility testing from a visual standpoint versus functionality is way more important. We work in a visual world, and that's how people do kind of accessibility testing, as well as the speed of which an image appears on the screen, right? If an image takes too long to load or the image does not appear correctly, that's also something we test into.
Sure, perfect. And that definitely ties in with another question that just got asked as well along a similar lines, which was we found that color schemes and their contrast affect image-based testing. And it was literally asking, what does Eggplant provide to manage this issue?
Yeah, we're actually going to get into how Eggplant deals with the color and contrast momentarily in the slide deck. I'll actually review the code and we'll actually dive into EPF, and I'll be happy to show you that.
Cool. That sounds like a perfect segue. I'll leave you with that.
All right, thanks. All right, so moving on. So how does Eggplant actually deal with this? This is actually a great question. So when we look for images on the screen, traditionally it was about precise logic, meaning I need to know this exact color, this exact shape, and that exact size differently. But as mentioned, right, there are different techniques that different other vendors use to draw the images on the screen. Because of this discrepancy, we had to do something called fuzzy logic. Fuzzy logic allows us to identify images that are very similar in color and shape based off a bunch of formulas and a bunch of information on the screen. So just real quick, these 5 bullet points kind of go into differences. So precise is what traditional image matching was all about, making sure that it's the very high degree of precision, making sure it's exactly the same image, make sure it's exactly the same color, the exactly same shape, and exactly the same size. That's all about precise. Precise would be important when you're dealing with like medical images, like DICOM, cardiology, heart images, things of that nature, CAD images, especially within the military. Precise is where you want to use most. Tolerance. Tolerance is a search type that's slightly different in pixels, meaning if they're drawn a little bit differently in terms of the actual pixels, that tolerance will be able to kind of handle that, which you'll see momentarily. Smooth is about kind of anti-aliasing. So not only is the text drawn differently, but the color is also different too. So instead of maybe like certain pixels appearing or disappearing, what we do is we kind of get the the average amount of pixels of size and colors and use that as smooth. Pulsing has to deal with if the image or text is kind of flashing on the screen, specifically an image. Smooth and pulsing is about if it's a text is kind of flashing on screen. These, beyond precise, the rest of the techniques are really used to look for images that are drawn differently on the screen. There's even a little bit more context within tolerance, smooth, and pulsing, and that's tolerance and discrepancy. Tolerance is specifically about the color variation of that. So if it's yellow versus slightly yellow versus a dark yellow, we can set a tolerance degree to accept all the different types of yellow. And discrepancy allows us to miss a certain number of pixels. So if certain images are being drawn differently, include or don't include certain images, discrepancy kind of allows us to handle that. So let's actually get into functional here. Oh, there we go. All right. So the first thing I want to show you guys is kind of the screenshot. This is known as clear type. But these are 4 different images of pretty much the same words. And if you notice, it's a quick brown fox jumps over the lazy dog. And from a visual cue perspective, they all look the same. The words, don't worry about this blue line right now, but you can see that the word the quick all pretty much looks the same. Some look slightly different than others, but for the most part, it's kind of hard to tell the difference. So what I did is I went here and I took a picture with an eggplant, right, just by simply clicking here and just doing capture image, or in this case I did wait for, or I can just click on this capture image, which took a picture of this. which allows me to present this image. Okay. Now I talk about pixels, I'm talking about those individual squares. So what I did is I edit image and kind of zoom up a little bit on it. So there's the image as a whole. Let me actually expand the screen a little bit. There you go. And what I did is kind of zoom up on the Q right here. So if you look at the Q here and all the other ones I kind of take, you can see there's a little bit of a difference. It's kind of hard to spot, so I'll kind of flip them a few times. But if you notice, this Q has a little bit more darker to it. Notice that the Q is not all black, but it's actually a mix of black, gray, and white pixels. Let me just zoom in a little bit more so you can kind of see it. So that's the top of the Q right here. And this top of the Q is 1, 2, 3, 4, 5, 6 pixels in length. And about 1, 2, 3 pixels in height. And you can see it's kind of a mix of black and gray. However, when I flip to the other one, flip to this one actually. Let me go back here and zoom in. You can see they're slightly different. And the best way to look is you look at the top left corner of it, it's more of a dark gray. If I flip back to this one, it's more of a lighter gray, right? So these 2 by 6 pixels, 1, 2, 3, 4, 5, 6, is what I'm really looking at. And you can see they're a little bit different in color, right? Now that being said, there's also a difference in length here, right? You can see this looks a little bit shorter than this one. Right, and this one also has a little bit different. Let me zoom in on this one a little bit. Right, so you can see there's, even though the Q is the same in all, like if you flip between this one, you can see this one's a little bit more black, right? There's 2 kind of gray pixels here. This one's more pure black, and this one's just light. So they're all slightly different, but it's so slight that it's hard to capture from the eyes. A computer can tell the difference because we're actually looking at these individual pixels, but when we visually look at it, it's hard to difference. So we use Eggplant to kind of identify that. Now, if the image is different, what we do is we increase the tolerance or discrepancy. That's in the information right here. So when I'm editing an image, I can change the tolerance or discrepancy or the type. Right? We talked about precise, looking for the exact images, or tolerant, which automatically adjusts the tolerant, smooth, which automatically adjusts the tolerance, and smooth here. So that being said, this is a actual working operating system. So if my application is on here, I can control it. But we're going to talk about this Chrome image right here. I'm going to show you going to delete this image and do it from scratch. All right. So if I want to click on this Chrome image, I can go into capture mode, highlight this Chrome image, drop this down, and say click. All right, which brings up this dialog box. We'll just call this Chrome, C-H-R-O-M-E. Click on Save. Right, and then we click on a Chrome image. Let me just kind of run that again. All right, so we're going to click on this image and press play. And we'll click on the image. However, if I play this image, if I play the script again and try to look for this image, right, this image on this screen, believe it or not, it's not the same image. What's different? There's a slight blue background here, right? That's the changing color we talked about earlier. Okay, so how do I deal with that? I try to click on this, Eggplant functional script will fail because the colors are actually different, right? Because I capture that little background, that little gray background. Let's fail. So you can see how this gray and this is really blue-gray, and it's really not finding it. This is the problem. When I look for precise, this is what's actually happening, and this is why images fail. So what we do is we increase the tolerance, right? The tolerance is the changing colors. That's okay. In this case, we're not changing on pixels, just because we're not changing the resolution, but we're just changing that. So we're changing it to 75. So if I click on Fix, which means I increase the tolerance to 75, and that's 75, what it really represents is the shift, as in, okay, if a pixel of RGB value is RGB, which is from from R values from 0 to 255, green values from 0 to 255, and a blue value is from 0 to 255. A slight red would be 255.00. So what that 75 really means is I can search for a pixel that's 255.00 or I think it was like 150 or like 125, 0,0. So a dark red to a brighter red. That's what the 75 means, and that's what's happening with that gray. That blue is changing to gray, which is increasing the pixels. So when I simply click on Fix and try again, now it doesn't matter if that image is highlighted, right? I run the script again, right, it's not highlighted, and I press play, it's able to click it. And if I press play again, as it's still highlighted, it can still find the image. So now it doesn't depend on what the color is. So that's what this tolerance and discrepancy changes and allows us to do. So I hope that answers your question. And this is kind of how Eggplant functional works. It's all about the fuzzy logic. All right, so moving back, just kind of go over again real quick.
So Randy, on that one, actually, we had a question from someone who's obviously been thinking about this and how they're going to put this into application, how they've been using it. Maybe they've actually already been using it, in fact. And the question is, you know, what do people normally do wrong here? What are the common gotchas, and how can they avoid them? And you've you know, very clearly covered off the background example. Is there anything else that you think are common gotchas about this, and where the pitfalls may be?
Yeah, that's a really good question. So remember, Eggplant's, as I mentioned kind of throughout the slide deck, it's all about what visual cue is used to identify this object. If you're capturing more context that is more contextual information that is not necessary, this could cause problems. Here's a good example. So I'm actually going to delete this image, right, as well as this code. So instead of capturing just a Chrome image, let's say I capture this, right, and I'm going to say click. And we'll call this again Chrome. Right. As you can see, I'm able to click on it, but let's look at the visual cueing that I'm capturing. I'm capturing Chrome as well as everything around it, okay? If this position changed, right, so first off, this code works fine, right, because it can identify it, so if I press play, you can see it clicks on it. But if this icon was moved somewhere else, and now I'm telling Eggplant to say, look for this image on this screen, it can't find it, right? Because I captured more of the visual cueing than is necessary for Eggplant. So the question is, when you look for the image, right, what are your eyes visually trying to do and recognize? And the real answer is, not only, it's really not the Chrome or the background, you're really just looking for the blue. So the only image you really need to capture is just kind of the inner working or inner guts of this image, right? This visual cue right here is enough to identify the object in whatever context. Again, if I run this code and press play, right, it can find it. Because the background doesn't change it, even if the background's colored, I don't even need to increase the tolerance or anything. But again, if I run this, right, it still finds it because I'm just looking at the visual cue for it. So something to mention or something to think about in consideration is what visual cue is presented to me on the screen in a meaningful manner. That's what I should capture, and it's something to take into consideration. So any other questions, Ben?
No, that's the one for now. Keep going. Thank you.
All right, perfect. So moving back to the slide deck here. All right. So again, the tolerance, smooth, pulsing, those are just different techniques that Eggplant uses, as well as tolerance and discrepancy. Again, all these are just proprietary ways of how Eggplant can find images on the screen versus precise. Again, the pixels, the tolerance, discrepancy, the colors do not matter unless you want them to matter, and then we just choose the precise format. If you know that it's going to be using different monitors, different images, different operating system, we might need to increase the tolerance or discrepancy. It's just something to take note of. All right, so any more questions about that?
Not around that one, no. I think keep going. There's a couple more questions coming in, but we'll keep them spread for the presentation.
All right, perfect. All right, so let's talk about the future of image recognition. So there are image recognition companies out there. The top companies are Google, IBM, Microsoft, and NVIDIA. And what they're using is they're looking for images on the screen, just as you see on the right-hand side. And they're doing it through very different means. Facial recognition, that's a huge thing on Facebook, as well as Google, right? Identifying people or like people on your pictures, facial shapes. Another good facial recognition is using like the golden ratio, which is a 3:3:16 ratio to determine if a person is beautiful. Symmetricals in the face or changes in the face, right? To detect cancer, things of that nature. So facial recognition is a huge part to play within the future of images. Another one is kind of text data, right? recognizing foreign text on the screen or seeing what it says and then converting it into computer readable code. This is also known as OCR, optical character recognition. This is already built into Eggplant functional, but there are a lot of other companies that are using it. Google, for instance, uses it as translated, meaning they look for the text maybe that's written in Japanese or Chinese or Spanish and translating that to English on the sign. So you can actually use your phone, point it to a sign, and it will automatically translate to English. For the Eggplant side, in terms of text recognition, is we automatically make sure that it is readable and in a readable format and can be switched to characters. So text recognition is pretty advanced right now, but it's always improving. And then there's, right now, that's pretty big, is kind of the street object recognition. This is all about self-driving cars, the Teslas, the Ubers of the world, right? Identifying stop signs, lines on the screen, moving cars, things of that nature. Or LiDAR is what it's called. What's actually happening is those cameras that are mounted on top of cars are taking, I think it's like 100, it's like 90 pictures per second, I think it is, or something around there. But what they're doing is they're taking all these pictures around the car and analyzing them as fast as possible to recognize dangers or possible problems in the future, and then calculate the motion of that or velocity of that object, right? If I take a picture now and in 3 seconds take another picture, I can see that object move in a certain position, distance, and from there I can say that this, within another 3 seconds, the likelihood of this image moving in that direction is 99, 98%. Finally is the kind of GUI object recognition. That's something that Eggplant is currently working on. Basically, for an application, within testing application, there are 18 different type of GUI objects on the screen. A good example is like bullet points, checkboxes, text boxes, links. Those are all GUI objects. And right now, Eggplant's working on trying to find these GUI objects based on how they look like. So the image on the bottom is kind of how all this recognition works. There's an input layer, a hidden layer, and output layer. Basically, the input layer is taking the picture of the screen. The hidden layer does all the coefficients and weighting to kind of figure out what the image is or what's in that image and determine what is going on. And the output layer is the actual output of what comes from the image process, so to speak, is kind of the output layer. That's what that bottom image represents. So I hope you guys enjoyed the slide. I hope that makes a lot of sense. And then if there's any final questions.
Yes. So Randy, that makes lots of sense. I've learned loads of things from that. Thank you. So there are a few questions. I want to go back on your previous demonstration, and we've got a question that looks like it's coming from an end user, and he or she has said that they often notice that Eggplant ends up clicking a different image than expected in case it isn't able to find the original image. Why is this?
So what you're doing is you're getting false positives. What it means is here's a good example. I'm going to look for this network icon. So if I just capture this guy, we're going to capture this. We'll call this network. All right. And what I'm going to do is I'm going to rip out a little bit more contextual data. So I'm literally just going to look for this. Okay. If I say click on this image, let's see what we were able to click on. Yeah, we clicked on this PC. I captured the network image, as you saw previously. We clicked on this PC, right? Why? It's because I probably didn't get enough context in that, right? If I did this image, let's just chop off even a little bit less than just that. Let's just kind of do it like that. If the tolerance is too greater, let's just put this kind of pretty high right now. Right? Even this, I might get some false positives. Let's find out what happens. Right, it was able to do network, which is awesome. So one of the things we need to look like is when it's trying to capture images, how it's captured, and maybe the increase of tolerance. If it's too much, and let's just increase the discrepancy as well. Let's just set 50 right now. And I tried to click on this. What happens here? Right? You can see it clicked all the way to the left hand. I didn't even click on a monitor. That was kind of interesting. Let's do that again. So if I press play, notice where it clicks. It doesn't even click on the monitor. It clicks right to the left of there. And it's usually because I have discrepancy and just clicking up there, that's pretty funny. And the reason why is because I have discrepancy and tolerance up so high that it's now recognizing false positives And because of that, I need to turn them down. So you kind of have to use your best judgment of tolerance and discrepancy, right? If it's okay for this image to be yellow or kind of yellow, that's fine. But if you don't care what the color is, then we're going to get problems. And then it goes back to that car example, right? If you're looking for a car that's completely black, sure, that's going to be really hard to do. If you're looking for a car that has some black, maybe some dirt, sure, that's a little bit more acceptable, right? Especially if I have a few dings or a few paint swamps. But if I say that looking for my car can either look for a black car or a black and gray car or a white car, right? Or just say it's dark gray. We'll do black and dark gray. Then my level of acceptance is greater, and I will have a harder time finding that specific image. So it's really kind of rule of thumb of what, in terms of tolerance and discrepancy, is set to see if there's any false positives. That is a little bit different than duplicate images. Of course, we can handle duplicate images. We can see the pixels kind of match the same. But I believe I believe what that question is referring to is false positives.
I think you're probably right. Hopefully that answers your question. Thank you, Randy. So on a slightly different tack now, someone has asked a question around usability testing, and specifically what types of usability testing can be done with this intelligent approach to image-based testing.
Yeah, so in terms of usability approach, basically it's just where the images are located. Are they located on screen or half on the screen, right? If there is, and I'll just pull up like or something real quick. Right, one of the things is, right, looking for this Google image. If this image is kind of half off screen, we'll obviously be able to identify that, right? Because that G will not be able to recognize. Something else too, again, that scalability factor. If the image is in a scale that is unrecognizable to the user, something like that, or, going reverse, right? If the scale is like this,
that's a great example.
It's kind of hard to know what to click on. So it's kind of that usability testing because we're looking for images. Again, this is kind of the idea of looking for that G on the screen. Let me go back to the regular zoom here. So that's not what I wanted. Oops. Yeah, but it's kind of looking for that G on the screen.
Yeah.
To kind of identify that. Let me get out of that because it's really annoying. There we go. And then getting back to that kind of scalability factor too. Let me reset this image. Right, it's also what's the acceptable scale of this image, especially with the testing. So let me just capture this G real quick, just to kind of show you that. Capture image, we'll just call this G. Right, so when we look for that image on the screen, right, we can identify the scalability of that image. Right, there's no scale, but if the image was scaled differently, right, and we search for it. But usually we can identify the different scale of that image and then click on that. All right, any other questions?
Yeah, so again, similar theme here. So the question is how do we validate multiple instances of the same image on the screen? Is there a way? For example, if there are 5 instances of an image?
Yes. So let's talk about multiple ones. I'm going to kind of clone this right here. And we'll use that G example again. There we go. All right, so there's 2 G's on the screen. If, again, going here and I click on search, you can see it says 2 found. So there's 2 G's on the screen. You can see the squares. Let me take this off light mode. Click search again so you can see it. So you can see there, this image says, okay, which pixels match the G on the screen? And you can see there's 2. Okay, so in terms of Eggplant functional, obviously we search for the most top left image. And I'll just do a move to, which is simply hover command. So I just say hover over this, and we can get it out of live mode. I'll click on the top most left G, which is that one. But if I wanted to click on the second one, there's the mouse. Just show you again, I'll move it real quick or press play. You can see it identifies that one. But if I want to click on that one, what we can do is we can say, okay, click item to of every image location. There we go. And when I run this code now, it'll click on the second G right over there. So that's how I do it. Every image location will return all the images of where it's located on screen. I'll just log this out so you can see. But this is the coordinates of the first location, this is the coordinates of the second location. Again, they're not locked, so when I move this here, right, notice this one is 925 by 722. If I run this again, the second coordinate will change, okay? So it's based off where it looks like on the screen. So every image location, or another command, every image rectangle is how you deal with every image.
No, that's so cool.
Next question, Ben?
Yeah. You've just been talking about coordinates here, actually, so it's a good time that someone has asked the question about how can you record coordinates in code, for example, for a particular object on a screen?
Well, remember, Eggplant looks for the images. If you want to go into the object, it'd be kind of the selenium and the coordinates that. Now we are using WebDriver to identify that, but again, in the browser, I'll just go to eggplant.io kind of for this example. All right, if you want to know where the coordinates are of a certain image, let's say we want to look for.
So let's say I want to look for the training and accreditation menu.
Yeah. So let's just say we're going to look for the support. Right, we want to make sure it's in the location area. So I'm just going to picture this. Do capture image. We'll call this support. Right, so if I say, okay, put image location of support to PPORT, right, and if we'll call this we'll call this SL for support location, and then I'll log SL, right, we can see the coordinates on the screen, and what we can do is we can verify this, so we can say, like, if you want to verify it like this, SL equals this.
Okay, so
then log correct position.
Randy, we're actually going to be out of time in 60 seconds, and I don't want to get cut off, and I don't want to leave people hanging. So can I suggest that if anybody does have any more questions, that they email them directly to the master that is Randy. So that is randy.hesse, randy.hesse @eggplant.io, and I'm sure that he will be very happy to help you out. Obviously, as you can see here, we can reach out to us on LinkedIn, on Twitter, and on Facebook as well. I just want to say thank you very much to Randy and also to everyone else for joining as well. I thought it was really informative. If you want to learn more about image-based testing, then please do take one of our free training courses, which can be found at Eggplant.io, training and certification, exactly as Randy was just showing you. But yeah, thank you once again for your time, and we look forward to joining you in future webinars. Thank you very much,
guys.
Take care, everyone.